All right, let's talk about Le Chatelier's principle. Why do we even need this? It's the shift of equilibrium. So we know that we have reactants on the left side and products on the right side. Let's consider one example. Here is the example of formation of ammonia. And on the left here, they are reactants. On the right, ammonia is the product. What are we getting from those reactants? So if equilibrium is shifted to the right, products are favored. That means that ammonia will be produced more than reactants. If equilibrium is shifted to the left, that's the other way. Reactants will be favored, therefore they will be produced more. Now, we have 4 different methods to shift the equilibrium. Let's talk about each of them. If, for example, we increase the concentration of N2, where the equilibrium will shift. Well, imagine you increase it, you make it too much. It's going to be too much for the system, so it's going to try to shift the equilibrium to the right because it's going to be too much on the left. And remember, every system is trying to achieve equilibrium, always. So equilibrium will be shifted to the right, therefore it favors the products. Now imagine if you decrease the amount of hydrogen. Well, there is going to be missing amount of hydrogens on the left. Therefore, in order to achieve equilibrium again, the equilibrium itself will move to the left. So equilibrium moves to the left, therefore favors the reactants. I hope that is clear now. Now imagine if we change the pressure. It's pressure and volume actually together. First of all, when we increase the pressure, we decrease the volume. Think about if we have, let's say, beaker and you have a press there, so you press on it and it's going down, more down. The volume will be smaller, right? This is one volume, this is second volume, this is third volume. You can compare. But the pressure inside here will increase, right? It will increase so much that it can even break the beaker itself. So that's why when we increase the volume, we decrease the pressure. We press on something. Therefore, we decrease the volume. So right now, let's talk about increasing the pressure. If we increase the pressure, in general, if we talk about pressure, we have to talk only about gases. So imagine if you had, let's say, for example, of course it's incorrect, but if we said liquid, let's say, it wouldn't count. We only count moles of gases. So on the left side, we will have 4 moles of gas. On the right side, we will have 2. This doesn't count. Of course, it doesn't count, of course, because it's not in the equation, but I'm just giving the example. So we have 4 and 2. So now, hear me out. If we increase the pressure, the equilibrium will shift towards the smaller number of moles of gas. So once again, increasing the pressure causes the shift of the equilibrium to the smaller number of gases, which is in this case 2 on the right and 4 on the left. The same way, if we decrease the volume, it's going to be the same thing. But if we decrease the volume, there's going to be, we are moving towards less gas. If we decrease the pressure, we move towards more gas. So if we decrease the pressure, let's say, decrease the pressure. Again, we have 4, we have 2, right? Why 4, by the way? 3 plus 1, right? We have 1 here. So we decrease the pressure and we move where? To more gas. Where do we have more gas? On the left, right? From 2 to 4. That's one of the principles. The second one. All right, now let me give another example of another reaction here. Let's imagine we're having combustion reaction, right? What is combustion? When we have organic compound, I'm not going to write it out right now, plus oxygen, it's going to be CO2 plus OH2. But you know that combustion is burning, so therefore we release the energy, release the heat. Therefore, this reaction is exothermic. So now it's kind of similar to our idea of increasing the concentration. If we increase the temperature, it's kind of similar to the idea even we increase and decrease concentration, same thing. Even we increase the temperature, we increase the heat over here, therefore it's going to be too much, so it moves over here. It's trying to distribute the heat equally, like in the house, right? The heat goes always up. It doesn't stay on the bottom, right? The top floors will always be heated more than the bottom. Same thing if we decrease the temperature, it's going to go from the left to the right. Equilibrium, of course, I'm talking about equilibrium. I'm calling equilibrium. It's all about Le Chatelier's rule. Well, these are the major reasons and options how to shift the equilibrium. One important thing, and it could be on the test, do catalysts increase or decrease equilibrium? How do they shift it? Well, catalysts, they do not change the equilibrium shift. So they do not influence it. Catalysts only increase the reaction. That is all. That's important to remember.